Hey everybody, Mr. Balistreri here. I want to thank you for checking out this video. The topic of this video today is sublimation. That's right, sublimation. Um, Sublimation is part of the water cycle. In fifth grade, and in a lot of the grades actually, but definitely in fifth grade, we learned about the water cycle this year. And we talked about the three main parts of the water cycle. So I'm gonna do some review, go over some of the things we talked about. You can see I'm outside today. It's a beautiful day. It rained for the last 2 or 3 days, so I'm taking advantage of the sun and the warmer temperatures to do this outside. But it's also going to afford me the ability to check out a couple parts of the water cycle right out here that we can see. So I'll hopefully be able to do that too. So as a review, you might remember the water cycle we learned about has three parts. We have evaporation, right, where water dries up and becomes individual molecules of water, H2O, and floats off into our atmosphere. That's evaporation. We have condensation. Condensation is when water gets back together into those droplets, and sooner or later, those droplets are too big to stay floating around out in the atmosphere, so they fall, and they fall as rain very often. Here in Wisconsin, when it's cold in a lot of places, if it's the right temperature, they might fall as snow or sleet, which is freezing rain. Sometimes in spring and summer, you have some pretty good updrafts, and it keeps pushing those droplets back up into the air and up way up high where the air is still pretty cold, and it keeps freezing and refreezing and refreezing, and hail is formed, and then it falls as hail. But all of these things are precipitation: rain, snow, hail, sleet. Anytime water, whether it's liquid or solid, falls from the sky is precipitation, which is the third part. So we have evaporation, we have condensation, and we have precipitation. Okay, those were the three main parts that we talked about. And of course, there were a couple other things that we mentioned as well in the water cycle. And one of those is runoff, okay, and collection. Those two things, runoff and collection, happen usually in between precipitation and evaporation. And those are the two we're going to try to take a quick look at out here. The main topic of this video, sublimation, though, I'm not going to describe that yet. And we're going to do a little set up a little experiment. I'll do it here, and you guys can do it at home. It's pretty simple. I know I didn't really give you any information about this yet, but all you need to do this, and if you need to turn off this video and go freeze some water, all you're going to need is a decent couple of ice cubes, right? They can be normal sized ice cubes. You could put water in a little Tupperware dish and make it a little bit bigger of an ice cube. But for the most part, all you need is an ice cube, and we'll take some measurements of that ice cube. You at home, you might just real quick measure it and see how the length, the width, and the depth of the ice cube is. I happen to also have a scale, so I'm going to weigh it, and that will set us up for our experiment involving sublimation. But let's get back to the water cycle for a second. So again, you have evaporation, condensation, precipitation, and that repeats. It's a true cycle. It happens over and over again, and it's really exciting stuff, right? I mean, without the water cycle, we wouldn't have life on Earth. You wouldn't have water for everything that's living, that is needed by everything that's living. And the great part, the really neat part about the water cycle, is it's like its own recycling process. The water we have now is the same as the water that existed even millions of years ago because it's not going anywhere, right? It dries up, it condenses, it rains back down, it collects, it dries up, it condenses, it rains back down over and over and over and over again. My really good friend had put it pretty good. My friend Bill Nye, you might have heard of him. He likes to say, when you're drinking a glass of water, you might be drinking what used to be dinosaur spit, and that's the truth. That water that you drink in your cup, at some point, was rainwater. It could have been any number of liquids that are basically made of water, right? So that water cycle just keeps it moving, keeps water going through those processes. Now, the one we're going to try to take a look at here outside is collection and runoff. So let me pause it here for a second. Let me pause it. Hold on. There it is. All right, here we are. I know this is kind of weird because I thought I was pausing and for some reason I wasn't, or it started filming again, but that's okay. I'm going to try to show you this here. See if you can see this. So I don't know. I hope you could see that. So I'm at a curb here, right at a sewer grid, and water is running down the street. It's just a constant stream of water. That's runoff, right? That's exactly what runoff is. It's when rain or melted snow runs downhill, right? It is nothing more than you could see right outside your door. Or if you were climbing a mountain and it was springtime and the snow was melting, you might see a little bit of a river flowing downhill, right? All of that is runoff. It's just the melted water, or melted snow, rainwater, or any other precipitation flowing downhill, trying to get to a collection spot. And a collection spot is a puddle, or it's a pond, or a lake, right? Or even an ocean. It's where water collects once it's done running downhill. And from there, it sits, right? It sits, and eventually some of it or all of it evaporates. In a second here, we'll be back to my yard, and I'm going to show you a collection spot, hopefully. Again, I can't see for sure that you're seeing this stuff, so hopefully this is going to work. But you'll see a collection spot in my yard right here. Let's see. Oh, there's even a little bug bouncing around in there. Can you see that? Right? It's just a puddle. That's all it is. On my sidewalk. That's collection. And it came from runoff, right? When it was raining yesterday, early today, water ran downhill and collected in that spot. Here's another one. This is a really squishy part of my yard. If you can see that, there's all sorts of little bugs floating around in there. That's another collection spot. And once the water runs downhill and collects in these collection spots, then it sits, and that's where it evaporates from. Whew, that was some good exercise. So, back to the water cycle. Evaporation, condensation, precipitation, runoff, right? Just running downhill, collection, right? Forms in puddles, ponds, lakes, oceans. Anywhere water collects and sits, it evaporates. I mean, water's always evaporating from any surface, even rivers. Rivers, I don't think of a river as collection. I think of it more as like a permanent runoff, right? It's always flowing downhill to a lake or an ocean or something like that. But that process, that evaporation, condensation, precipitation, runoff, and collection, over and over and over and over, and it usually follows, or always follows, that same process. This is where sublimation comes in, okay, the topic of this video. Now, to describe sublimation, I have to remind you of a couple other things. If you think back to when we were talking about matter, not what's the matter, but matter, M-A-T-T-E-R, right? In our classroom, we defined matter as everything. Everything is made of matter. And We talked about atoms, right? The tiniest part of a pure substance. We talked about molecules, which is when you take at least two of those pure substances, right, that we find on the periodic table, and we join them together chemically to form molecules. And we always talked about one of the most common molecules that's easy to think about, H2O, water. Water is a molecule, right? It's not one of those pure substances made of only one thing like gold or copper or oxygen, right? It's made of hydrogen and oxygen. Two hydrogen atoms, one oxygen atom, chemically bonded together to form a tiny droplet of water. And you get enough of those droplets together and they condense. That's what a drop of water is. Get enough drops of water together and you have a puddle. Get enough puddles together and you have a lake, and so on and so on. Um, so anyway, sublimation is this idea of going from solid water right to gas. Normally, if you want to take solid water and turn it into a gas, you would melt it first, right? You got to give energy to those molecules because even the molecules of a solid are in motion. That's what we needed to remind you guys about. All molecules and atoms are in constant motion. The atoms and molecules of a solid, they're they're kind of tightly stuck together and organized in a pattern, but yet there is a vibration, there is motion in solids. If you give it energy, like if you take a solid like wax or ice and you give it energy, you speed up the particles that make that solid, and sooner or later they break away from each other and melt and become a liquid, and they have more energy and more motion. Give it even more energy until they get so much energy that they fly off that surface of that liquid. That's what boiling is, or evaporation, right? It's when a liquid becomes a gas. Sublimation is skipping the liquid phase. In other words, it goes from a solid like ice to a gas like water vapor, but it never melted, right? This is taking place in really cold places. What this goes to prove is that even solids have some motion to their tiny particles, right? Because even solids, every once in a while, one of those particles breaks loose and floats off into the atmosphere. It happens slowly, much slower than when it's coming off a boiling liquid, right? Or much slower than even a puddle that's evaporating kind of slowly. Like that puddle we just looked at in my yard, that thing's probably going to be there for 2 more days before it totally evaporates. But if I took that water and put it into a big kettle and put it on the stove, I would get that thing evaporated in a matter of 15 or 20 minutes, or maybe an hour or two. So what we're going to do to test sublimation, we're going to get ourselves an ice cube, right? We're going to do a couple of measurements on it. At home for you, all you really need to do is pay attention to how big it is. Maybe measure it with a ruler. Is it about an inch long and an inch wide and an inch high, right? Just get some rough estimates. So I'm going to measure it and figure out about how big it is. And I'm going to weigh my ice cube so we can also test to see if we lost not only the size but the weight. Then we'll quickly put it back in the freezer. Now you're going to want to put this somewhere safe, okay, in your freezer. You don't want to put it back in the ice bin because you're going to need to look at that same ice cube. And you don't want somebody messing with it, okay? You don't want someone putting it in their soda or in their glass of water. You want to put this one aside. So maybe let your family members know that you're doing this experiment. That way, um, they won't use your ice for something else. And the other thing, like if being stuck at home all this time, mom or dad or somebody's talking about cleaning out the freezer, make sure that doesn't happen while you're doing your experiment, because what we want to see happen is that that ice shrinks and gets smaller even though it never melts, because that's what sublimation is, right? Slowly molecules of water come off of that ice cube, right? Kind of proving that even the particles of a solid have motion. And the only way for us to tell if that's really happening, and it's not a hard way at all, you will see it shrinking, right? It should get smaller over time. And if you weigh it, it should weigh less. Um, Let me just warn you, when you do your measurements, it's got to go quick, right? You go get your ice cube, you measure it, and then you put it back in the freezer. So I'm going to do that. Hopefully it works. I'm going to push pause and go get an ice cube real quick and have it all set to do these measurements and use the scale, and we'll weigh it and I'll write those measurements down. All right. And I'll be right back. All right, I'm back, and I just realized I was not using the pause and resume button accurately, so I don't know if this video is working right now. I'll be very sad, but I got to do this quick as not to lose it. So my ice cube is 1.5 by 1 by 1.5, and the weight is 26 grams. 1.5 by 1.5 by 1. All right, I am going to pause this again and get that. All right, so it is back in the freezer. Again, my measurements were my ice cube was 1.5 inches long by 1.5 inches high by 1 inch deep, and it weighed 26 grams. Um, Again, I am not sure this video is going to work out the way I planned at this point, just because I was not pausing and unpausing correctly. So I'm going to have to watch it and see. Hopefully it worked out. If not, I'll just have to reshoot it, I guess. So that's it. You have an ice cube in the freezer, and you know how much it weighs if you were able to weigh it. If you weren't able to weigh it, that's all right. Just get a quick measure on how long it is, how tall it is, and how wide it is. And all it has to do now is sit in the freezer. And since every substance, solid, liquid, or gas, has motion to its tiny particles, right? Those molecules of water are always moving. Every once in a while, one's going to break free and float off into the atmosphere. And it should shrink and get smaller and lighter. And it might take a while, right? We might not check back on this thing for a week or so. All right. And what I'll do, once we have a few experiments set up, they're all going to take a little time. Once we have them set up here, and some of you setting them up at home, what we'll do is I'll make a video like once a week checking back on all of the experiments that we have running, and we can think about those. And of course, you can always go, if you're one of my students, you should go to my calendar on my website to see what kind of math and reading I'm assigning. And if you have questions or you want to ask about the experiments, you can always email or have your parent send a message on Remind. All right, hopefully this worked out, and hopefully you can get this little experiment going. Remember, don't let your brother or sister use your ice cube in their soda. And again, thanks for joining me, and I will see you next time.